Summarizing numerical data sets is literally going to summarize everything we've done so far in Unit 6. Now, you have to keep in mind as you're picking what standard deviation you're going to use. If you're using population, like you have all of the data values, or if you need to use sample because you have just a few of the data values. Most of these answers are going to come straight from your calculator. You have to be able to operate the calculator. When it comes to a quiz and a test, I can't tell you anything about the calculator, okay? So, the first problem says Niles scored 70, 74, 72, 71, 73, and 96 on his 6 math tests. And then I ask you a variety of questions. I need you to find the mean, the median, the standard deviation, the interquartile range. I need to know if there's any outliers so that you can tell me the best measure of center and variability, which is also spread. So if I need all of those things, there's several ways to do this, but what's the way we've been focusing on? You're going to put it in the calculator. So you need that data in the calculator. Well, I already have data there, so I'm going to clear it out. So I need every person actively typing these numbers in their calculator. So you have 70. Niles scored a 74, a 72, a 71, a 73, and a 96. And then you need to take a few seconds to go back and make sure that what you typed is really the data that you saw. So now that we've got the data in the calculator, I need you to calculate some statistics. And to calculate the statistics, you're going to do second stat. You only know one variable. You only know what Niles scored, so you're going to use one variable, statistics. Niles' data is in L1. You want a frequency of 1, and you're going to calculate it. So, if it's a test, I can't tell you what each of these means, but I'm going to tell you right now. N is the number of data values. X bar is the mean. S is your sample standard deviation. Omega is the population standard deviations. Then you have some summations that you don't really need to know right now. You have a minimum, your Q1, your median, your Q3, and your maximum. So, if you're looking for the mean test score, you're looking for X bar. And Niles' average or mean test score is a 76. All right, I'm looking for his median. I got to get the calculator where I can write. I'm going to find median, which is MED. And his median test score. That means if you put those scores in order from least to greatest and quite literally moved in and found the number in the middle, that would be a 72.5. Now, I need the standard deviation of Niles' test scores. How many test scores should Niles have? It says 6. How many do I got? 1, 2, 3, 4, 5, 6. So I have all of them. So since I have all of them, I'm going to do the population standard deviation, which is omega. So I'm going to write omega to remind myself that I did the population. And what is a 3 going to do to a 0? Nothing. It's going to leave it a 9. So the standard deviation is 9 above and below the average, which is the mean of 76. So then my next question says, what is the IQR, the interquartile range? Now, on your formula sheet, let me grab one so I can read what it says to you. On the formula sheet, which you will have access to always, it tells you that your interquartile range is Q3 minus Q1. The interquartile range is the distance between the third and the first quartile. So if I want to do IQR, I'm going to take Q3 and I'm going to subtract Q1. So let me go find Q3 and Q1. Q3 is 74, my friend says, and Q1 is 71. So what's 74 minus 71? 3. I don't mind doing that math in my head. So as of right now, I've got each of these numbers. Now, the next two questions, E helps me get F. You see, if I ask you about the best measure of center and variability, which is spread, that is based on the idea of, do I have an outlier or not? Because an outlier is a number that is either really high or really low. And it's kind of like playing tug of war with your mean. Look at Niles' scores. Does any one of those scores stand out as odd to you for Niles? 96. Why does 96 stand out to you? It's way above. Normally, our boy Niles is making in the low 70s, which is all right. He's passing. But as soon as he made that 96, what did that 96 do to his average? It pulled it up. So it's like tugging on the average. It's making it look like he's been making 76s when he really hasn't. So if you have an outlier, and I'm real suspicious of that 96, it's going to manipulate that mean. So if you do have an outlier, you use the median, because the median is the middle, no matter if the highest score is 96 or if the highest score is 75. All right? So I've got to find out if there are outliers. Well, on my formula sheet, it says outliers are more than 1.5 times the interquartile range below the first quartile or above the third quartile. If I want to go below the first quartile, I'm going to subtract from the first. If I want to go above the third, I'm going to add to the third. So this is what I call my boundaries. I have a lower boundary and I have an upper boundary. I got to figure out what are acceptable values. So my first quartile is 71. I'm going to go 1.5 times the IQR lower. My upper boundary is to take that upper quartile and go above it 1.5 times the interquartile range. Now that has to come from me. I have to go calculate that now. So 71 minus 1.5 times 3, make sure I type the right stuff, is 66.5. So if there's any numbers, any test scores lower than a 66.5, it's an outlier. The upper boundary is 74 plus 1.5 times 3, and that is 78.5. If there's any score above it, that's an outlier.
96.
96. Why is 96 an outlier?
It's greater than the...
Very good. It's greater than the upper. So are there any outliers? Yes. 96 is an outlier.
Oh, we don't gotta explain.
We're not going to now because you just did. At this point, you know why. Now, if I said explain, you would say exactly what Jose said. You would say because it is over the upper limit or greater than the upper limit. So then, the last thing we got to do is figure out the best measure of center and variability. You're going to notice that I use variability and spread. I flip them because both of those words can mean the same thing. Variability is how far spread out the data is. I don't know what the end of course test is going to word it like. So I'm looking for the best measure of center and the best measure of variability, which is spread. And so to do that, I'm going to look back at yesterday's notes about measure of center and spread. When we said if there is not an outlier, then we're going to use the mean and the standard deviation. But if there is an outlier, the mean is getting pulled and it's tricking you. It's not really not that high or not that low. There is an outlier, we use the median because the median is the middle no matter what the highest number is. The median is a quartile. Therefore, you use the interquartile range to go with it. So since we have an outlier, what is the best measure of center? Median. And because we have an outlier and use median, what are we going to use for variability? IQR, interquartile range. And then why? There you go, because there is an outlier. Now, a lot of times with my data, I only have like one outlier. But please know that you could have no outliers or you could have multiple outliers, okay? So it's not like it has to be just one. It can be multiple or it could be none. For our next example, Aaron has diabetes and needs to monitor his blood sugar level. He measures his blood sugar each day before he eats dinner. Aaron's results for the past 10 days are in the table below. Blood sugar levels for any person before meals should be between 80 and 120. Now, you have two sets of numbers. This side is simply telling you that on day 1, his blood sugar level was 109. On day 2, his blood sugar level was 115. Which set of numbers are we really trying to analyze? The blood sugar. So these are the numbers you need to enter into your data. So I'm going to go to my data. I've already got numbers there, so I'm going to clear it. I'm going to enter each value one time. Okay. Now, obviously, if it repeats, you would enter it. I'm going to enter each day, I guess I should say. And then I'm going to go back real quick, and I'm going to make sure that every number I entered is what I was supposed to enter, because if one number is wrong, my whole data set is wrong. So I'm going to give you just a second to enter your data. So now that we got our data in there, we're going to start answering some questions. I'm going to need to find things like the mean, the median, the standard deviation, the interquartile range. So I need those statistics. So I'm going to do second stat, one variable statistics. All right, so the first question asks me for the mean. If I'm looking for the mean, what statistic is that in my calculator? That's X bar. And so X bar is 100.4. If I'm told to calculate the median, that would be if you took all his blood sugar levels, put them in order from least to greatest, and found the one in the middle. The calculator can tell you that, but what am I looking for? MED, for median. So his median blood sugar level was 99.5. You notice how close those are? That tells me that that data, because the mean, the numerical mean, and the median, which is literally the number in the middle, since they're pretty close, I'm thinking that that data is really close together. All right, we gotta let my friend in. It says C, determine the standard deviation of Aaron's blood sugar levels. Now, I want his blood sugar levels. I have 10 days. The only thing I have is 10 days. Do I have 10 days? All 10 days? I do. So in this case, I'm looking for my population standard deviation because I have all of his past 10 days. So I'm going to look for omega. So omega is my population standard deviation. And that's 8.15. So what's that 5 going to do to that one? 8.2. And then when I'm trying to find an interquartile range, if I needed to, I could grab my formula sheet. That's Q3 minus Q1. So I've got to go find Q3 and Q1. Q3 is 107 minus Q1 is 93. 107 minus 93 makes an IQR of 14. That means that the middle half of the data is only 14 blood sugar points away from each other. Now, ultimately, I'm going to need you to be able to tell me what is the best measure of center and the best measure of spread to represent Aaron's blood sugar level and why. But that is based off of knowing if I have outliers. So I've asked you to determine if I have any outliers. And to do that, my formula sheet says outliers are more than 1.5 times the IQ or interquartile range below the first quartile or above the third quartile. So I'm going to take the lower boundary. I'm going to take 93 and I'm going to go even lower by 1.5 times an IQR. To get the upper boundary, I'm going to take that third quartile of 107 and I'm going to add 1.5 times 14. So I got to calculate those. I'm going to type those in. 93 minus 1.5 times 14. I get a lower boundary of 72. So if anything is lower than 72, it's an outlier. I get an upper boundary of 128. So if anything is higher than 128, it also is an outlier. So now I need to look at my data. Is any one of Aaron's blood sugar levels lower than a 72? Okay. What about higher than a 128? No. So what does that mean? There's no outliers. There is no number that is way higher or way lower that's yanking on and tug-of-warring on that mean. Since there are no outliers, what is your best measure of center? The mean. And when you use the mean for center, you're going to use the one that is based off of the mean, which is the standard deviation. And why did we decide to use these? Not because we just wanted to. Very good, because there are no outliers. So let's look at example 3. Example 3 says, consider that Aaron's data is just a sample of his blood sugar levels from the entire month. What would the standard deviation be for his typical blood sugar reading then? So if those 10 days were just a sample, how does that change his standard deviation? What are you looking at then? You're looking at the sample standard deviation. So you would be looking at 8.59. So what's that 9 going to do to that 5? Make it a 6. So you would use sample standard deviation is 8.6. Now, what does this tell Aaron about his blood sugar? So your standard deviation, what that does is that tells you about where his blood sugar will fall regarding the mean. What was the mean, the average? His average blood sugar was 100.4. So what this tells him is he can expect his blood sugar level to be within 8.6 of the mean of 100.4. If he keeps eating the way he's eating and drinking whatever he's drinking, whatever he's taken in to make his blood sugar level be what it is, he can expect and predict that when he takes his blood sugar level, it's going to be 8.6 in between, give or take, some higher or lower, the 100.4 average mean. Number 4 says, a company keeps track of the age at which employees retire, and it's considered early retirement if their employee retires before turning 65. The age of some employees who retired are listed below. So I got all those ages. Those represent some employees who retired. I need to find the mean, the median, the standard deviation, the interquartile range, the outliers, so that I can find the best measure of center and spread. So what is the best way for you to find the mean, the median, the standard deviation, all those statistics? Take your data and put it in the calculator. So you go to data, there's stuff there, so you push data again and you clear it out. And you're going to enter each age. Each age represents a different employee that retired and the age at which they were when they retired. So now that I've entered my data, I'm going to go back in. I'm going to make sure that what I typed was what I was supposed to type. Because if any number is wrong, the whole thing's wrong. So now that I've got my data and I need to do my statistics, I'm going to do second stat. And I'm going to be really careful to read whichever statistics it says. I need the mean. So if you were helping your friend, what does the mean show up as on the calculator? It shows up as X bar. So 55.18. What's an 8 going to do to the 1? Make it a 2. If you were looking at a multiple choice test and all of the answers were whole numbers, If I round this to a whole number, what's it going to be 55. Because most of the time if we talk about what age we're going to retire, we say at 55. Not like 55 and part of a year.
Like 2 months.
Yeah, something like that. All right. So next I want to calculate the median age of retirement. The calculator has been programmed to put all of these numbers in order from least to greatest and find the one that's in the middle. Well, you're looking for the median, and on the calculator, they abbreviate that MED. And the median age of retirement at this company is 56, according to this data. Now, here's the one that you might get wrong if you didn't pay attention to a very small phrase. What is the standard deviation for retirement at this company? I know that I have to figure out if I've been given a sample of the people that retired or if I've been given the entire population that retired. This last sentence says the age of some employees who retired are listed below. So did I give you the population or the sample? I gave you the sample. So since I gave you the sample, you're looking for that sample standard deviation in your calculator. And 8.56, what is, oh, I'm sorry, you can't see. What is the 6 going to do to the 5? Make it round up to a 6. So I'm going to ultimately want to know what's the best measure of center and spread. Well, that's based on the outliers. And what do you need to know to calculate the outliers? Q1, Q3, and your interquartile range. So let me find my interquartile range. So my IQR is going to take Q3. So let's find Q3. Q3 is 59 minus a Q1 of 51. And what is that interquartile range then? What's 59 minus 51? 8. So my IQR is 8. Now, I can look at my data and predict if I have an outlier. But just because I think I have an outlier doesn't mean it is. So I'm going to find my lower boundary and my upper boundary. So my lower boundary is going to take that Q1 and it's going to make it go below. So I'm going to subtract 1.5 times an IQR of 8. My upper boundary is going to take that upper quartile, the third quartile, and make it go above by adding 1.5 times 8. So then I grab my calculator and I do 51 minus 1.5 times 8, and I get a lower boundary of 39. I add 1.5 times 8 to the 59, and I get an upper boundary of 71. So my question now is, did any employee retire younger than 39? Yeah, who? 38. I don't know why he retired early. Maybe he was disabled because, you can retire young with a disability kind of thing.
He was just better than everybody else.
Or he won the lottery and came into some money. So I definitely have one outlier. That's lower than the lowest boundary. Do you have any employee that retired when they were older than 71? Yep, 73. So you actually have two outliers. You have a lower outlier and an upper outlier. So, yes, I have outliers, and that is 38 and 73 are outliers. So I want you to think about what that's doing to your middle, your average, your mean. You got the guy that stayed till he was 73 pulling the average up. You got the person that retired at only 38 pulling the average down. So it's like they're in a tug of war with the mean. So is the mean the most reliable at this point? No, it's being tug of war. Since you have outliers, you need to go with the one that's in the middle no matter what. So what is the best measure of center for this data? What's going to be in the middle and doesn't matter what you do with it? That's your median. Your median is the number in the middle, and it does not care what the numbers actually are. It has no impact how big or how small the numbers are. It's in the middle, and it is what it is. Since you use the median, which is a quartile, you're going to use the interquartile range to describe the spread. And the reason we chose this is because there are outliers. Those outliers are going to manipulate our data.